Hi, I'm Dr. Kirsten Ellis from Monash University, and I'm presenting Bespoke Reflections, creating a one-handed Braille keyboard on behalf of myself and my co-authors Ross DeVent, Reuben Kirkham, and Patrick Olivier. So, as you all probably know, technologies are not always designed to be accessible, and assistive technologies do not cater for unique disabilities, for example, for people who have multiple disabilities. Do-it-yourself enables customization, which means that it can be designed to suit specific needs. Bespoke AT is where skilled professionals use a higher level of crafting and refinement to create new custom forms. So Ross is a co-author on the paper. He's blind. He only has the use of one hand, is fluent in Braille, and he does music transcription, which created a specific problem that we needed to solve. He uses a Braille display, which some of you may or not be familiar with, so that anything that on his computer can be interpreted or translated into Braille so that he can read it. And I make things. So Braille, I'll just introduce for those who don't know very much about it. Basically, Braille consists of 6 dots, and they can represent every letter in the alphabet, punctuation, but they can also represent math and music notation as well. So our methodology was to co-design a one-handed Braille keyboard using an iterative prototyping process, and then conduct a structured reflection on the process. So when we were undertaking the prototyping process, there are a few things that we did. So one of them was when I was making something. So it was Ross's job to explain how Braille works and what his needs were. And it was my job to try to come up with the best design that I could to suit his needs. So rather than giving him just one thing and ask one prototype and saying, do you like this? I always presented him with at least 2 prototypes so that it gave us a way of discussing. So the first version we had was like a piano keyboard, and to create 6 dots with 5 fingers, you moved your hand, your thumb, between dot 5, dot 6, and dot 5 and 6 combined, creating 6 letters or 6 dots out of 5 fingers. So the first version was a keyboard which was flat, and the second version was more like a cup, so having your hand wrapped around something. There's no reason to have a flat keyboard. And we could really try some innovative ideas. We weren't constrained. The problem with the cup was that because of the Braille display, it became obvious that eventually he had to drop the cup, feel the Braille display, and then re-pick up the cup, which took time. So what we did was, in good maker style, we put a lunchbox on top of the keyboard, the Braille display on top of the lunchbox, and then tipped the cup keyboard over, and so that it ran in a line and became more like a bridge. So he could smoothly move his hand from the keyboard to the Braille display and back. And from that point on, we went with more a bridge style design. We did various prototypes to try to work out the best placement of buttons, whether to put the buttons underneath, the placement of how far apart they should be to be comfortable, whether they should be in a straight line, Ross really liked having the buttons along the front. I didn't, but I wasn't building it for me. I was building it with Ross, and he was telling me that because Braille display has dots on buttons on the front, he was used to having things on the front of the keyboard, so that was an appropriate place to put buttons. So some of the other keyboards we tried, one of the hardest things was actually getting buttons that were appropriate. We tried various momentary buttons and really getting them strong but soft and clicky, and just having that right feel was actually probably one of the hardest things in the process. So the final keyboard that we came up with was a bridge, and I'll just show you the details. So it had a space return and backspace keys, which is very similar to what's on a Braille display. And then it had dot from the bottom of the ramp, 3, 2, 1, and then dot 4, and then dot 5, dot 6, and dot 5 and 6 were along the front and operated with the thumb. So what we found with the structured reflection was that there was a real difference in the knowledge that we both had. And it was our ability to work together and be honest that made it possible to actually build the one-handed keyboard. There was a real role of iteration in prototyping. So just lots and lots and lots of different prototypes, different buttons, different placements to get it right. The quality of the relationship that we had was necessary to build. And we were both spend a lot of time on it, but saw it as a really worthwhile effort. And there were a whole lot of things that we learned from the process in terms of the quality of the relationship, the tacit knowledge, that really going into something in a great deal of detail. So, and learning the procedures for making things. It's a really worthwhile process to be involved in, and you don't need multiple people to learn a lot. You can learn a lot from working very deeply with just one person that you're building for. I think Ross is a real pioneer, though, very willing to try different things. And we do need people who are prepared to actually work their way forward. There's some ethical concerns that if Ross invested in actually learning this technology, then it can be a problem if there's no way of maintaining it. And university structures often come in, develop software or develop assistive technology, but don't really have a company or a structure to be able to support that into the future. And also how we go about funding those builds as well. So it was a very intensive process that yielded important insights. It was really important that we actually had a really good relationship and trusted each other. It helped to produce a novel assistive technology designed by and for the end user so that it genuinely fits their needs. Thank you.